Good morning, students. I hope you all are doing it very well. So, today let's start with Geography chapter number 3rd, and the name of the chapter is Motions of the Earth. Very easy, very simple topic. So, let's start without any delay. Let's talk about the introduction of this chapter. What does this chapter want to say, or what we're gonna study in this chapter? All the planets in the solar system has two types of motion. First, they spin on their axis and they go around the sun. The spinning moment of the Earth on its axis is called rotation. The Earth also moves around the Sun along a fixed path called its orbit, and this movement is also known as revolution. The Earth's axis is an imaginary line joining the North Pole and the South Pole. The axis is tilted at the angle of 66 by 1 by 2 degree with the plane of the Earth's orbit, or 23 by 23 1 by 2 degree with the vertical. This tilt is called the inclination of the Earth's axis. Okay, so let's get understood with the introduction of this chapter. What does this chapter wants to say? First, all the 8 planets which are in the solar system, they had two types of motion. First, they spin on their axis, means the place where they goes round and round on that place on their axis. And second is that while rotating on the place, they also move around the sun. Okay, the spinning moment of the earth means the spinning moment of the earth on the particular place is known as rotation, and the earth also moves around the sun while rotating on its axis on a fixed path. It is known as revolution. Will explain you again. The spinning movement or the rotating movement of the earth on the particular place on its axis is known as rotation, and during rotation the earth goes around the sun on a fixed path. This is known as revolution. The earth's axis is an imaginary line, means the axis of the earth on which earth rotates. It is an imaginary line which joins the north pole and the south pole. Okay, the earth is tilted. The earth, sorry, the axis on which the earth rotates is tilted at the angle of 66 1 by 2 degree with the plane of the earth's orbit, or 23 1 by 2 degree with the vertical. And this tilt of the earth with the plane of earth's orbit or with the vertical, this tilt is known as inclination of the earth's axis. Okay, very simple. So now let's discuss with the new topic, rotation. The earth takes around 24 hours to complete one rotation, and we consider this time to be one day. The earth is spherical in shape. Only one half of it gets light from the sun at a time. The half which faces the sun has daylight, while the half which is away from the sun experiences night. If earth didn't rotate, then one half would be permanent daylight and become very hot, while the other half would be permanent night, cause freezing condition. In such condition, there would have been no existence of life. Effect of rotation. Occurrence of day and night, sunrise in the east and sunset in the west. Deflection of winds and ocean currents. Let's discuss and understand what rotation is all about. The earth on which we live, it takes around 24 hours to complete one rotation, and these 24 hours we consider it to be a day. Okay, the earth, if we talk about the shape of the earth, it is spherical in nature, as only one half of the earth gets sunlight at one time. Means, if we talk about the shape of the earth, it is spherical in nature, and only one half at a time gets the sunlight. The half which faces the sunlight has day, and the other half which is away from the sun have night time. What if when the earth didn't rotate, what will happen? The one half which is experiencing the sunlight will always have the day and become very hot, and the other half, which do not facing sunlight, will have night time and will cause freezing condition or the cold condition. In during such conditions, there will be no existence of life. Means no life can exist if Earth won't rotate. Effects of rotation means how rotation affects. 3 points, very simple. First, occurrence of day and night, important. Sunrise in the east, sunset in the west. Second point, and changes or deflection in ocean current and wind currents. Okay, let's move forward with the next topic. Let's talk about revolution. As the earth spins on its axis, it also goes around the sun. This movement of the earth is called revolution. Rotation and revolution takes place simultaneously. The earth revolves around the sun in an anti-clockwise direction along a fixed orbit. It takes 365 days and 6 hours to complete one revolution, and this time is considered to be 1 year. For the sake of convenience, we count only 365 days in a year, and after every 4 years, the balance of 6 hours add up to a day, that is 24 hours. This extra day is added in the month of February. Every 4 years, February has 29 days instead of usual 28, and the year has 366 days, and such a year is known as leap year. Effects of revolution: variation in day length of day and night, vertical and slanting rays of sun, occurrence of season. Okay, let's discuss about one more important topic, which is revolution. As the earth spins on its axis, means as the earth rotates on its axis, and during this time it also moves around the sun. And this movement, when earth moves around the sun while rotating on its axis, is known as revolution. Rotation and revolution both takes place simultaneously. Means as rotation takes place, revolution will also takes place together. Both will take place at a time and together. The earth revolves around the sun in anti-clockwise direction, okay, and in a fixed orbit or in a fixed path. This takes 365 days and 6 hours to complete one revolution, and this time we consider it to be a 1 year. For our convenience, we count only 365 days in an year. The extra 6 hours or the balance of 6 hours in every 4 years added up together, and it becomes 24 hours. That is 1 day, and that one extra day is added in the month of February, and the February will become the day of 29 instead of 20 usual 28 days, and that year will have 366 days, and which we call as a leap year. Okay, what are the effects of revolution? Very simple, only 3 points. Variation in length of day and night, means sometimes in summer day are longer, and in winter night are longer, so it's the effect of revolution. Vertical and slanting rays of sun, okay, and occurrence of various seasons. Let's move forward. Variation in the length of day and night. In summers the days are longer, and in winters they are shorter. The variation of length of day and night occur because the earth revolves around the sun with its axis always inclined at 66 1 by 2 degree. At the equator the variation is minimum, and the day and night are equal in length throughout the year. So away from the equator, days are longer in summer and the nights are longer in winter. At the poles, variation is maximum. There is a continuous daylight for 6 months during summer and continuous darkness for 6 months during winter. The Earth axis is always inclined in the same direction. The North Pole is inclined towards the Sun, while the South Pole is always turned away from it. During this time, all places in the Northern Hemisphere have longer days and shorter nights. Places in the Southern Hemisphere will have shorter days and longer nights. The North Pole gets continuous daylight while South Pole remains in continuous darkness. After 6 months, just opposite of the above happens. Let's discuss how the variation in length of day and night takes place. In summer, we all know days are longer and in winters the days are shorter. This variation in the length of day and night occurs due to the earth revolves around the sun with axis inclined on 66 1 by 2 degree. If we talk about the equator, the variation of length of day and night is minimum as they are equal in length on the equator throughout the year. As we move away from the equator, the days will become longer in summer and the nights will become longer during the winter. At the poles, that is at the North Pole and South Pole, this variation is maximum. There is continuous daylight for 6 months and then there is continuous dark or night for next 6 months during the winter. Means daylight during the summer for 6 months and night time during the winter for next 6 months. The earth axis is always inclined at the same direction, means the inclination of the earth axis is always same. The north pole is inclined towards the sun while the south pole is inclined away from the sun. Okay, during this period all the places in the north pole or in the northern hemisphere have longer day and shorter night, and places in the southern hemisphere will have shorter days and longer night. The North Pole will get continuous daylight while the South Pole remains in continuous darkness. And after 6 months, the opposite of above happens. Means what condition of northern hemisphere was in summer, and in after 6 months, the same condition of the southern hemisphere will there. Okay, let's move forward again. Vertical and slanting rays of sun. The portion of the earth that is tilted toward the sun receives vertical rays while the other portion receives slanting rays. Vertical rays give more heat than slanting rays because vertical rays are concentrated in a small area while the slanting rays are spread over a larger area. The vertical rays pass through a shorter distance of the atmosphere than the slanting rays, thus they lose heat. Okay, very simple, very easy. Let's talk about the vertical and slanting rays of sun. What the difference between those? The portion of the earth which is tilted towards the sun or which is towards the sun, it receives vertical rays, means direct rays, while the portion which is away from the sun, it receives slanting rays. Okay, vertical rays or the direct rays, it gives more heat as compared to slanting rays because vertical rays or the direct rays, they are concentrated or they are focused on a smaller area while the slanting rays, they are spread over a larger area. The vertical rays pass through a shorter distance of the atmosphere than the slanting rays, means the straight rays, they pass on or they go for a shorter distance of the atmosphere as compared to the slanting rays, and due to longer distance the slanting rays lose their heat. The vertical and slanting rays of sun. The position on June 21, summer solstice. North pole is inclined toward the sun and south pole is away from it. The rays fall of the sun fall vertically on the Tropic of Cancer 23 1 by 2 degree. Major part of the northern hemisphere are lit by the sun rays. As a result of that, the days are long and hot and it is summer in the northern hemisphere. This position on June 21, where the sun shines vertically on the Tropic of Cancer, is called summer solstice. Let's talk about the day of June 21, which is also known as summer solstice. As we all know, North Pole is always inclined towards the sun and South Pole is inclined away from the sun. The rays of the sun, which, or the rays which comes from the sun, they fall vertically or directly on the Tropic of Cancer, which is 23 1 by 2 degree. Major part of the northern hemisphere during this time are lit by the sun rays, and due to this, days are long and hot, and you experience heat or summer during that time in the northern hemisphere. This position on June 21 means the position on June 21 where the sun rays fall vertically or directly on the Tropic of Cancer, which is 23 1 by 2 degree, and this is known as summer solstice. What is summer solstice? The days are long and hot, and it is summer in the northern hemisphere. The position on June 21 where sun shines vertically or the sun rays fall directly on the Tropic of Cancer, then it is known as summer solstice. Okay, let's move forward. Let's talk about the winter solstice. The position on December 22, winter solstice. The south pole is inclined towards the sun and the north pole is away from it. During winter season, the south pole is inclined towards the sun and the north pole is away from the sun. And due to this, the rays of the sun fall directly on the Tropic of Cancer, 23 1 by 2 degrees south. Due to this, the days are long because sun rays falling vertically and hot there, and it is summer in the northern hemisphere during winter in the northern hemisphere. If, on December 25th of every year, Christmas is celebrated all over the world as it is winter in the northern hemisphere as in England, the USA and India. But it is summer in the southern hemisphere if we talk about the continent of South America, Australia, etc. When the sun shines vertically on the Tropic of Capricorn, when the sun rays falls directly on the Tropic of Capricorn, then winter solstice happens. Okay, let's move forward. Vertical and slanting rays of sun. The position. Let's talk about the position on March 21st and September 23. Both North Pole and South Pole are neither inclined towards the sun nor away from it. Means the position of the Earth on March 21st and September 23. The Earth axis is straight. It means neither North Pole or and South Pole. Both of them are neither inclined towards the sun nor away from the sun. The sun rays fall vertically on the equator. It means the rays from the sun fall directly on the equator, and due to this, days and night are equal duration throughout the world on 2 days, which is 21st March and 23 September. As a result, uh, as a result of sun rays falling vertically on the equator, the days and night are in equal duration through on every part of the world on 2 days during the year, that is March 21 and September 23rd. The reason in both the northern hemisphere and southern hemisphere is similar, means the season on northern and southern hemisphere, the seasonal condition are same, means neither too hot nor too cold. These 2 days where there is equal day and equal night throughout the world, this day is known as equinox. What is equinox? Means the 2 days, March 21 and March 21 and September 23rd, those 2 days where days and night are equal throughout the world, then it is known as equinox. On September 23rd, it is autumn on the northern hemisphere. On the equator, the sun shines on vertically overhead. If we talk about on any day, what are the condition of sun rays on equator? On any day of the year, sun rays falls vertically on the equator. Therefore, there is only one season on the equator, and due to this, throughout the year there is only one season on the equator, that is too hot and long summer. Okay, let's move forward. Let's talk about the season. We have divided the year into four kind of season. First is spring, summer, third is autumn and winter. And we experience these four seasons mainly because of two reasons. First, due to revolution of earth, means around the sun, and due to the inclination of earth axis, which we have read during the first slide, means the inclination of earth axis at a fixed angle and direction. Okay, on 23rd September, the sun shines vertically over the equator, causing equal day and equal night all over the earth. On this day, northern hemisphere has autumn while southern hemisphere has spring. Let's talk about the various different seasons on the earth. We divide the year into four different seasons: spring, summer, autumn, and winter. We all know these seasons occur due to two main reasons. First is revolution of earth, and what is revolution of earth? Movement of earth around the sun on a particular path which is known as orbit, and the inclination of earth axis at a fixed angle and direction. If we talk about the 23rd September, the sun shines vertically on the earth's equator, and due to this there are equal day and equal night all over the earth. And on this date, northern hemisphere will have autumn and southern hemisphere will have spring. So students, here comes the end of this chapter. I hope you have understood this chapter. Read it again and again so that you will be able to avoid any kind of confusion. Okay, take care and see you soon.